Another example to understand the bending moment and shear force values, consider a simple cantilever beam. Consider a simple cantilever beam loaded with a UDL. For example, I am taking 5 kN per meter over the distance of 12-meter span cantilever. So we are going to see how the shear force and bending moment values can be calculated and how the shear force diagram and bending moment diagram can be drawn. Okay, first of all, we have to assess the support characteristics. What are the unknowns present in this support condition? Left side only, this structure is having support. Right side, there is no support. So for the fixed beam condition, one vertical reaction is possible. That is, vertical direction arrest is possible. One horizontal arrest is possible, as well as one moment arrest is possible. So if there is some arrest, definitely there will be the magnitude of reactions in vertical direction and horizontal direction and the moment depending upon the loading conditions. Why I am telling about the loading conditions means this beam is subjected to only the perpendicular load. This beam is subjected to only uniform distributed load of perpendicular direction, that is y direction. So there is no horizontal loading in this beam. Hence, this horizontal resistance will not created in this support condition because there is no horizontal load. If some beam section is subjected to an inclined loading like this, if you resolve this load, then you can divide into two components, one vertical and one horizontal. Then there will be equal and opposite force of the same magnitude of this. For example, if you take some 10 kilonewton of horizontal load while resolving some force, you will get the same 10 kilonewton in the opposite direction as a reaction. In this case, all the load, that is one UDL, which is acting for a particular span, that is 12-meter span, is completely loaded with 5 kilonewton meter. That's why it is represented as UDL. So this UDL is a purely perpendicular loading, y direction loading. So there is no need of considering x direction reaction. There is no resistance in x direction because there is no load at all. So summation of effects is not there. That is HA is not there. Horizontal reaction at A is not there. We can take A and B. We only have RA. We only have RA and moment at A. Okay? Moment at A. So here the reaction at A is upward and the direction of moment, I am only assuming the direction because the reaction at A is upward because the load is downward. So we can assume the direction of RA because there is no any other direction of loading, only perpendicular loading is there, downward direction is there. So definitely the resistance will be towards the upward. So that's why we are assuming the direction of RA. But moment we can able to judge anyhow, we can prove it by the equation. First of all, I am assuming some direction of moment at A for the given loading of 5 kilonewton per meter and 12 meter span. So I am going to write the moment equation at A to get the value of moment. Moment equilibrium equation. What is the moment equilibrium equation? Summation of moment equal to 0. That is the moment equilibrium equation. So here I am going to draw the direction of force as well. So this is the direction of moment I am assuming. So this is the direction of force about the support beam because all the loads are downward direction. So it will rotate along this direction about the A point. So consider these two directions and the loading magnitude also. First of all, I am considering MA, the direction of MA as positive, because if you equal to 0, then any minus sign or plus sign will counteract each other. So I am considering MA as positive, which is anti-clockwise, so that the clockwise direction is negative. So MA is positive. While writing the moment equation, MA should not be multiplied with any distance because MA itself is a moment. So MA minus, because the load is rotating opposite direction to this moment. 5 into 5 into 12 is the total load. What is the total load? If UDL is acting for a particular distance 12 meter, the total load is equal to 5 into 12. So it is already you have studied. Anyhow, I am recalling the concept. 5 into 12 is the total load into the centroid of this loading is at 6 meter. Centroid of the loading is at 6 meter. So into 6. And also the centroid should be about this point of consideration, that is A, equal to 0. So MA equal to 5 into 12 into 6, which is 360 kilonewton meter. So I am going to calculate in other mode. That is, this is one mode. I am assuming as anti-clockwise direction. The second mode I am assuming as a clockwise direction. That is towards upward, and the same UDL is considered. That is 5 kilonewton per meter. Now write the moment equation. Summation of moment equal to 0. So you name it MA. So MA. So above the A support, it is rotating along this direction. And now concentrate on the rotation of the loading. It is also in the same direction. About A, the loading as well as moment is all in the same direction. So MA, it is a moment quantity, so no need to multiply it with the distance, plus 5 is the loading UDL, and total load is 5 into 12, and the centroid about the A point is 6 meter, so into 6 equal to 0. So now MA equal to minus 360 kilonewton meter. So what is the difference between this value and this value? The sign changes. Why it changes? First I am assuming it is anti-clockwise, then the result is positive. Second case I am assuming it is a clockwise, then the result is negative. What it means? If you get a positive value, your assumed direction is correct. Your assumed direction is correct. If you get a negative value, your assumed direction is wrong. So if you get a negative value, you should change the direction of assumed quantity, or it can be any moment or it can be any force value. If you get a negative value, it means that the assumed direction, the considered direction is not correct. So the real characteristics of this moment is anti-clockwise. Okay, now we get the moment. That is the moment is anti-clockwise of 360 kilonewton meter. Now calculate RU. So in this equation, we need not include RA because taking moment about A includes RA into 0 distance. There is no distance to multiply. So this RA equation will not present in this step. Okay, now calculate RA. How it is calculated? 5 kilonewton per meter load or 12 meters. Actually, there is no another support to take over this perpendicular load. Only one possible support is RE. So overall, all the load is carried by this support A only. So directly calculate the total load. What is the total load? 5 into 12 is the total load. That is 60 kilonewton. So the total load is absolutely carried by the supporting A. So it is 60 kilonewton. Okay, 60 kilonewton. So now we got both the values RA as well as the moment. RA is 60 kilonewton and the moment is anti-clockwise of 360 kilonewton meter for the given meter. So now it is simple to draw the shear force diagram. Consider a section. We already know the left up as well as right down is positive. If you consider a section, the left side upward as well as right side downward is considered to be positive. And if you consider this section, so consider the left side direction of this reaction, it is upward. So it is positive. So you mark up to 60 kilonewton. So it is a UDL. I think you well known about if it is a point load, the linear variation of shear force is a straight line. If it is a UDL, the linear variation occurs from 0 point, and if it is a UVL, it is a parabola. If it is a UVL means uniformly varying load. If it is a UVL, it will be like a parabola. And this is for shear force diagram. For bending moment diagram, it is one step upward. It is a linear, it is a constant variation. So you will get linear variation in bending moment. And in second one, it is a linear variation. You will get a parabola in one. And it is a parabola. So we will get a higher order curve for the second degree curve for the bending moment. So with this information, RA is 60 and the shear force diagram we are drawing, SFD we are drawing. So it should be, for the UDL, it should be a linear variation. So it should be a linear variation to become 0. At this point, there is no support. So the shear force as well as bending moment is 0 here. Shear force and bending moment equal to 0 at B point. Okay. Next one, BMD. BMD means we have only one moment. You mark this direction. This is head and tail. Tail means tension. It is indicating tension. So for a cantilever beam, in a cantilever beam, the tension is always upward. The tension is always upward. That's why the reinforcement is provided on the top. Reinforcement is provided on the top in case of cantilever beam, while in case of simply supported beam, the reinforcement is provided according to this moment direction, either in bottom as well as or in top. But in cantilever beam, the top reinforcement is provided to counteract this tension. So you mark this bending moment, that is a parabolic equation of 360, also in negative quantity, also in negative. It is a parabola curve considered to be, so it is negative in magnitude. Okay, I think you should be able to analyze this support characteristics, whether it is having a horizontal reaction or vertical reaction or a moment, and where the bending moment is 0. This all should be well known to you before starting the structural analysis subject.